Hello, we're Group 16, and now we would like to show our second demo for the course Simulation in Computer Graphics. In our first showcase, we present the effect of the vorticity confinement on the fluids. We can see the vortex which is created in the fluids using the vorticity confinement. We also implemented solid boundaries in the fluid simulation. Here you can see a car-like shape built using these boundaries. It is visible that the fluid is not able to penetrate through any of the solid boundaries. We implemented the rigid bodies to have complex shapes built of polygons, such as the boat we can see to the right. Additionally, rigid bodies can act as if they are static when they have a mass and inertia equal to infinity, as seen in the triangular iceberg. When the two bodies collide, only the boat gets pushed. In the following showcase, we present the collision between two circular bodies with the same mass. It is visible how the force after the collision is equal between the bodies. Next, we show how the force after collision changes when the bodies have a different mass. The rigid circle has 5 times the mass and is thus less affected by the collision. Lastly, we experimented with having a body with mass 10 times larger than the other one. To demonstrate how the collision of multiple bodies works, we generated the 8-ball pool configuration of rigid bodies. The collision behaves similarly to its real-world example, as the furthest ball from the impact gets accelerated the most. In this scene, we can see how the fluid is affected by the movement of the solid objects around the scene. By pressing V once, we can see the velocity field, and by pressing it twice, we can see the pressure field. We can show a similar simulation for rigid bodies. If the force transfer is off, the fluid and bodies don't affect one another. However, when the transfer is on, we can see how any force applied to the body results in a fluid flow and vice versa. We integrated the particle system into the fluid simulation. In this scene, we generate the cloud simulation that interacts with the circle rigid body. Note that the particles are affected by the fluid simulation as well. Our final example shows how a cloud simulation interacts with the fluid forces.